This is Chapter 1, Lecture number 2. We're on page 2 in the packet. Before we continue with the CFC story, we are going to investigate matter and its characteristics. Matter is anything that has mass and occupies volume, takes up volume. When we talk about mass, we're talking about the amount of matter an object contains. When we talk about volume, we're talking about the amount of space an object occupies. Air is matter. It has mass and it occupies volume. An inflated tire weighs more than an empty tire. There is a difference, though, between mass and weight. Weight is the amount of matter and the pull of gravity on that matter. So we all know that an object weighs less on the moon because the moon has 1/6 of the gravity of the Earth. So if you weigh 180 pounds on the Earth, you will only weigh 30 pounds on the moon, but you will still have the same mass. Mass doesn't change, weight does. Matter can be thought of macroscopically, so what we can see, microscopically, and submicroscopically, which would be atoms, molecules, protons, neutrons, electrons. So we use models to show a visual representation, or verbal, or mathematical, of experimental data that we collect. We use models to represent things that are hard to visualize. A graph is a model. In this class, we use the scientific method. We start with an observation, which can be qualitative, which relates to the 5 senses, or it can be quantitative, which involves a number, through the use of an instrument. So if we say the mass of a book is 2.2 kilograms, that is a quantitative observation. if we say the book has a blue cover, that is a qualitative observation. From observations, we develop a hypothesis, which is basically a guess to explain the observations. We then carry out a series of experiments. The independent variable is the variable that is changed. We change it. We change the temperature of a system. We plot the independent variable on the x-axis, and then we see how the dependent variable reacts to the independent variable. So the dependent variable changes in response to a change in the independent variable. A control is a standard for comparison. We come up with a conclusion, which is based on the information obtained. From this, we look at laws, which is a relationship supported by many experiments. And from this, we develop a theory, which is an explanation of a natural phenomenon based on many observations and investigations over time. So the atomic theory, which took hundreds of years to develop, is the theory of the atom. So back to our story of the ozone layer. In the 1970s, scientists hypothesized that CFCs, chlorofluorocarbons, broke down atmospheric ozone. Scientists around the world started collecting data. They found out that not only CFCs, but also we use carbon tetrachloride, CCl4, methylchloroform, 1,1,1-trichloroethane, so it has the formula CH3, CCl3, and we'll get into this later. We're also increasing, and both of these compounds also harm the ozone layer. So the Montreal Protocol in 1987 was an agreement by nations to phase out these compounds. So it was the scientific method in action as the world came together to solve a rather serious problem. But still, the ozone layer is not expected to start recovering until after 2060. We're going to finish up today with a quick video on mass versus weight.
This brings us to an often confused concept of measurement. The terms weight and mass are often thought of as the same thing. People use the two terms to mean the same thing. This is a grave mistake, because weight and mass actually measure two different things. Weight is the amount of gravitational pull on an object. The weight of an object is a determination of how strongly gravity is pulling down on that object. We usually measure weight with a spring scale. A spring inside the scale is stretched by the pull of gravity on the object. But strength of gravity changes from place to place. For instance, a person who weighs 60 kilograms on Earth would only weigh 10 kilograms on the Moon. The Moon is about 1/6 the size of the Earth, and it therefore has much less gravity. That's why this lunar rover is bouncing around so much on the Moon, where everything would weigh less. However, the mass of an object isn't affected by changes in gravity. That's because the mass of an object is a measure of the amount of matter in an object. If we take the balance scale to the Moon, the weights are affected as much as the object being massed, so the reading is the same as on Earth. For most situations on Earth, mass and weight will appear the same, but it is important to know that they are really measuring different things.